Okay, this is writing an equation and drawing its graph to model a real-world situation. It says owners of a recreation area are filling a small pond with water. They are adding water at a rate of 30 liters per minute. There are 600 liters in the pond to start. Let W represent the amount of water in the pond in liters, and let T represent the number of minutes that the water has been added. Write an equation relating W to T and then graph your equation using the axis. Okay, the relationship between W, which is how much water you have in the pond, and T, which is how long it takes you to add it, I pretty much know that W, which is how much water is in the pond, starts out at 600 because it said there are 600 liters in the pond to start. So right now, if W is the amount of water in the pond, I know that I'm starting with 600. But I'm going to add to that because they are adding water at a rate of 30 liters for every single minute that goes by. So they're going to add 30 liters per minute. Per minute. Per minute? Per minute is what I don't know. How many minutes? So X is, oh, sorry, not X. They said use capital T. T, capital T, 30T. Let T represents the number of minutes that water has been added. So in my little box right here, I'm going to type in that equation. And you can rearrange it. You can, if you want, you can write W is equal to 30T plus 600. It doesn't matter which order you put it in, but that's my equation. All right. And then they're going to want me to graph it. Well, remember, there's 600 liters in the pond to start. That means at time zero. At time zero. And you can even tell they've labeled it. T is right here on the x-axis, and W, if you can see it, here's a little T right here, and here's a W right there. So you're going to start this graph on the y-axis at 600. It should start right there. And then at the 1 minute mark, they would have 30 times 1 plus 600. You'd have 630. But this thing only goes in increments of hundreds. So and 30 doesn't go into 100 evenly. It's going to take a while to figure that out. So I'm going to have to use this little symbol, this little thing right here to pick another point. I already know that my first point is going to be at when time is 0. There's 600 liters in the pond. Pick any number you want for T. I don't know. How about I pick, let's say we pick 2 this time. Let's say at the 2 minute mark. I'm going to stick 2 where this T is. So W is going to equal 30 times 2 plus 600. And that's going to equal 30 times 2 is 60. 60 plus 600 is 660. But I can go over to 2, right? Here's 2. But then where's 660? I don't know. Is it there-ish? I can't tell. So that's where I'm going to have to come over and use this thing. So what I'm going to do now is I'm going to switch over to, that's not it. Where did it go? There it is. Okay. Okay, so I'm going to type into this equation, this box here. What was it? W equaled 30, and you'll notice I'm using capitals because that's what they told me to do, plus 600. So there's that. And then I come over here, I'm going to be drawing in a line, so use the line tool. And the first point is at 600, but I can't do the second point. Well, let me do this now. Okay, plot a point. Let me X that out. Hang on. Let's see. Will this let me plot a point? There's a point right there. 600. Boop. Did it plot it? Okay, and then, yeah, it looks like there's a point right there. And then I'm going to type in the other point. Do not approximate. So the other point was when x was 2, y was 660, and then plot point. Plot point. Oh, okay. X that out. Sorry. I'm not used to this. And then I want to connect the dots, I guess. So click there, and on that point. Okay, now I'm going to hit check. Yay, I did it right. Woohoo! All right, hope that makes sense.